Hi, I'm Dr. Alice Christie.
And I'm David Hendershot.
And I am the founder of Tynkertopia. We've been serving Flagstaff youth for about 2 years. We are a STEAM community center focusing on creativity, inquiry, and STEM and STEAM skills and understanding. It's a place where kids can come and experiment, discover, build, create, and learn while they're having fun. This year, we are providing 750 STEAM kits during the Festival of Science. And our STEAM kits will be distributed at various places around town. And they feature the creation of 4 different bridges using the engineering design process to create them. There's 5 steps in the engineering design process. The first is to figure out what kind of a problem you want to solve. And we were creating bridges that would go across some kind of an expanse. So our problem was how to create a bridge. And we also had to consider what materials we had that were readily available around our house, that were recyclable, that weren't very expensive. Those were the constraints that we needed to think about. So that's step 1. Ask yourself, what's the question? Step 2 is to imagine. Let's think of all the different ways that we might be able to build a bridge. What materials do we need? How could we test our bridge? And in your packets, you have 4 different bridges. My challenge to you would be, now that you've created 4 bridges, think about a 5th way or a 6th way that you could create a bridge, one that we have not demonstrated for you. The next step is to make a plan. In your bag, we have created that plan for you because we've provided you with some suggested directions for how to create it. Your plan might include a drawing and include the steps that you would want to be doing. And then next, you want to create your bridge. And using the materials that you've gathered, using the sketch that you've created. And once you've got your bridge, the most important part is to test it out and then improve it. How could you make your bridge go farther, support more weight, be more stable? And then that begins the engineering process all over again. This is like a cycle. And this time you'll be asking a different question. You'll be saying, what kind of a material would make my sway bridge a little bit more stable? But this time you're asking the question based on your experiments that you've done so far. I'm hoping that this will help you think like an engineer, like a scientist. And I've printed this on nice cardstock, so you could put this on your refrigerator and keep it and use it as a model for many of the other experiments that you want to do at home. We have 4 different bridges for you guys to build. The first bridge is a folded paper bridge. The second bridge is a rolled paper bean bridge. And the third bridge is our paperclip and straw truss bridge. And our 4th one is a string and craft stick sway bridge. So we're going to show you how we made each one of these. Here are your 3 pieces of paper: print, cardstock, and construction paper. So what we want to do is to make a fairly small fold, maybe a 1/2 inch, and make the crease nice and tight. And then flip your paper over and make a second crease. And you're going to continue doing that with all 3 pieces of paper. Your 3 completed folded paper bridges should look something like this. After you build the bridge, experiment. Which one is strongest and why? One of the ways that you can test your bridge is to take coins or rocks and put a coin or a rock on each one of your bridges and see how much it will hold. And all of this can be recorded in your notebook. How many nickels, how many dimes, how many pennies, and then what is the total number before your bridge collapses. Now we're ready to start bridge number 2. And in our bag, we've got a piece of cardboard. We've got 3 pieces of old newspaper, recycled newspaper. Place your paper on a flat surface and then create a little triangle. And then you're going to make a tiny, tiny, tiny little fold, maybe 1/8 of an inch. And we're going to just continue holding it down really tightly and rolling and rolling and making the folds as tight as we can. And it gets easier as you go. And here we are, we're almost done. There we go. And now we have a pretty sturdy little bridge. And then we're going to put our cardboard on top. You could have taped that beforehand, or you could leave it open, whichever you would like. And now let's test some coins. See how it goes. So far so good. And you want to keep adding and adding until your bridge will not support the weight anymore, and record your observations in your observation notebook. And here's bridge number 3. Again, made out of things you can commonly find around in your household. This particular one is made with paper clips and straws and another piece of cardboard. So here's your cardboard. Here's your directions in English and Spanish. Here's the straws that we're going to use. And then we've got 60 paper clips. First thing we want to do is take all the paper off of the straws. Yep, that looks good. So our goal is to create a triangle with our straws, and we're going to use paper clips to hook it together. To assemble a paper clip, it's really quite easy. You're just going to slip one right inside the other. Now I'm going to take my first straw and insert the paper clip, and I want to flip this around so that I am putting the round end in. And I'm going to do my second straw and push it to make it stable. I'm going to repeat and repeat. And now I'm almost ready. I have my triangle almost complete. I'm going to insert this paper clip and insert the final paper clip. And voila, I have my first triangle. Now, let's talk about the next triangle, because it is going to be like this. So I simply need to hook a third paper clip into each of these junctions. So that's a little trickier, but totally doable. So I'm going to hook this in, flip it, and I'm almost done. I need a third triangle, a third paper clip right here. Wrong direction. And I will use this paper clip twosome that I created earlier. And then we will have our second triangle attached to our first triangle. We've got our first two triangles completed. So you're going to use the rest of your straws and your paper clips, and you're going to connect all of the triangles together, and let's see what it's going to look like when it's finished. There is your truss bridge. Now it's time to test. We want to compare the cardboard bridge with no trusses and the cardboard bridge with triangular trusses. What do you predict? Which one will be able to carry the most strength? David, my assistant, is going to put on the water bottle. Oh no! And as we all know, scientists don't do things just one time. They test multiple times. So for today, we'll just test once again and see if we get the same result. We did. So now it's time for you to record in your observation notebook. What do you predict will happen? Will the truss bridge be able to hold more weight than the straight cardboard bridge? Finally, we've got a fourth bridge, and it is made out of string and craft sticks, and it's what we call a sway bridge. In your bag, you'll find your directions. You've got your string, you've got some straws, and you've got, whoopsie, jumbo craft sticks. We're going to cut each of our straws into 4 pieces. So I'm going to find the approximate middle and do a little snip here and a little snip here. So each of your straws will be divided into 4 pieces. Once you have all your straws cut into 4s, what you want to do is take your straw, and we're going to put 10 quarter straws onto each of our strings. Now that we've got our 10 small straws on the string, our next step is to lay out our popsicle sticks. Next step is to take our string and our straws and bring it over on top of the popsicle sticks. And we already have some tape all ready. I'm going to tape that one right here, and then I'll go ahead and tape that one right here. It's best if you have your tape already cut, and it's best if your tape is less wide than your popsicle stick. And I'm going to move this one a little bit over. And there we have our first set. This is what your finished bridge will look like. You're going to tie both ends of your string to chairs, knobs on doors, so that you can test your bridge. We're going to try this with all of our coins. And it held, but it wiggled a little bit. Let's take our water bottle and see what happens when we release our water bottle. All right. David, wasn't this fun?
It sure was.
We had a great time building the bridges, designing them, finding the materials. We hope you had as much fun as we did. Thank you so much for participating in the Tynkertopia sponsored STEAM Kits that were distributed as part of the Festival of Science this year.